Hello, Assalamualaikum. So we are going to continue with topic number 2, which is equations, inequality, and absolute values. Lecture 1 of 4 for this chapter. So the first subtopic is about equations. So the learning outcome, all of you should be able to find the equations involving indices, surds, and logarithm. So we've learned about indices, surds, and logarithm in chapter 1. So for this part, we are going to solve equation involving those parts. Content. Okay, so an algebraic expression contains one or more terms that are combined through basic operations such as addition, subtraction, multiplication, or division. Some examples are 2x plus 5, 3x minus 1 all over 1 plus x, 3 minus 6x, 2 log to the base 4 of 1 minus x plus 10. However, an equation is a mathematical statement that states two algebraic expressions are equals. Some examples in one variables are 2x plus 5 equal to 0, 3x minus 1 all over 1 plus x equal to 4, 3 minus 6x equal to square root set of x plus 1, 2 log to the base 4 of 1 minus x plus log to the base 2 of x equal to 10. So all of these contain the equal sign to emphasize the equation. Okay, so let's move on to the first equation, which is the index equation. So there are three methods of solving index equation, which is the first one is to compare the base and index of term on the left hand side and the right hand side. And the second one is putting log on both sides of the equation. So we are using the log. And then the last one is by using substitution. Okay, so we are letting something equal to representation in the equation. Okay, so let's try to solve the equations. So for example 1, we are trying to solve equation of 7 to the power of x plus 1 equal to 12. So which one of the method we should use from the three methods? Okay, either we want to compare, or we want to put log, or we want to use substitution. So this part, to determine which method we should use, it's all about experiences. So what you have to do is to practice. For this one, it's better to put log on both sides. Why? We only have one term on the left side and another term in the right side. So putting log on both sides, we can just directly use the common log, or you can use natural log, because both can be calculated by using the calculator. So putting log on both sides, we have log of 7 to the power of x plus 1 equal to log 12. So by applying the law of logarithm, this power can we bring to the front as the coefficient of the equations. So it will be x plus 1 as the coefficient. So we don't have x plus 1 here. And then because we want to solve x, what we can do is to divide everything with log 7. So on the left side, we left with x plus 1. On the right side, we left with log 12 over log 7. So what is x? X is equal to log 12 over log 7 minus 1. Okay, to get x, we can minus 1 on both sides. So it's left with x equal to 0.277. Okay, for the next example, solve the equation 27 to the power of x plus 1 equal to 9 to the power of x minus 1. So which one method we should use? Is it log, or comparing, or substitute? Okay, for this one, we must check either, even though we have one term on the left side and one term on the right side, we have to check whether our base can change into the same base. Okay, so if it can be changed into the same base, means that we can just compare the index. Okay, for this one, 27 and 9 is related. Why? Both are from the base 3. So what is 27? 27 is 3 to the power of 3. And 9 is equal to 3 to the power of 2. So what we can do, we just simplify the index here. So what we get as the index, so we have 3 to the power of 3x plus 3. And the right side we have 3 to the power of 2x minus 2. So what we can do is just compare the index. So the left side we have 3x plus 3. The right side we have 2x minus 2. So what is x? Just solve the equation directly. So we get x equal to negative 5. Okay, for example 2. So we want to solve the following equation. Equation A is 5 to the power of 2x plus 1 equal to 6 multiplied with 5 to the power of x minus 1. Okay, so which one method we should use? So for this part, we don't have one term on the left side, one term on the right side. We have two terms on the right side. So what we should do for this one, directly we use substitution. Okay, so we let this index here separated. So we have 5 to the power of 2x. So plus 1 will be multiplied with 5 to the power of 1. So that we can represent this 5 to the power of 2x equal to 5 to the power of x. How to write down this one? This is 5 to the power of x to the power of 2. So if we let u equal to 5 to the power of x, so we replace everything with 5 to the power of x with u, what we have after this is, by using substitution, we will have 5 to the power of x is equal to u. So this part is u square multiplied by 5. So 5u square equal to 6 of u minus 1. So this is an quadratic equation. So we can solve quadratic equation as usual during the SPM. We have to factorize. So we have 5u minus 1 multiplied with u minus 1. So what is our u? Our u will be 1 over 5 and 1. So is this the final answer? No. What we want to find is x. What we want to solve is x. So substitute this value u into the equation here. So we have what? U equal to 5 to the power of x. So 5 to the power of x equal to 1 over 5. So 5 to the power of x equal to 1. So solve for both of these. So this 1 over 5 is actually can be written as 5 to the power of negative 1. So what is x? X equal to negative 1 for this part. And then for the right side is 5 to the power of x equal to 1, which is equal to 5 to the power of 0. This is the properties of indices. Okay, so comparing both sides, the indices on both sides, so we have x equal to negative 1 and x equal to 0. So both of these are the answers. Compare, kita guna compare base and index of term on left hand side and right hand side for solving the value of x after we use the substitution method. Okay, so for question B, e to the power of 2x minus 3, e to the power of x plus 2 equal to 0. So we have three terms here, so we cannot separate into two parts, left hand side and right hand side. So directly we use the substitution. So what substitution we should use? So we have e to the power of 2x here and e to the power of 2x here and e to the power of x here. So what we can do is to separate this power by using the rule of indices. So we have e to the power of x to the power of 2. So by letting u equal to e to the power of x, so what we have, the next equation is, by using substitution, we will have u square minus 3u. So u square minus 3u plus 2 equal to 0. So we can solve the quadratic equation as usual. So we have u minus 2 multiplied with u minus 1 equal to 0. So what we have is u equal to 2 and u equal to 1. So this is not the final answer. What we should do is to replace back u with e to the power of x. So e to the power of x equal to 2. Another one will be e to the power of x equal to 1. So how to solve for this one? So we cannot change these two into base e, because e is an irrational number, the same as 1, but 1 we can replace it by e to the power of 0. But how about 2? It's easier for you to use log on both sides. So we applying log, natural log on both sides. So what we can have is natural log of e to the power of x equal to natural log of 2. So don't forget to put on both sides. So we have here and here. And then for this part also, natural log of e to the power of x and natural equal to natural log of 1. So what is natural log e to the power of x? So we can bring the x as the coefficient in front of the log. So we have x natural log e, which is equal to 1. Okay, so x directly equal to natural log 2. How about this one? The same as the first part. So we can bring x as the coefficient. So x natural log e is equal to x. So directly the answer will be x equal to 0. Okay, so the same as if we use the indices for this part. This is because we have the properties, right? But for the left hand side, we cannot use any properties. So the answer is x equal to natural log 2 and x equal to 0.